Configuring a mesh of point-to-point VPN is a nightmare. What if your VPN could dynamically build spoke-to-spoke tunnels on demand? Welcome to DMVPN. DMVPN stands for Dynamic Multi-Point Virtual Private Network. It allows us to securely connect multiple remote sites without the headache of manually configuring point-to-point VPN tunnels everywhere. DMVPN is the combination of following technologies: MGRE, NHRP, routing, and IPSec. MGRE lets us create a single tunnel interface that connects to multiple sites. But MGRE interface doesn't know who's out there. That's where the NHRP comes into picture. NHRP, also known as Next Hop Resolution Protocol, you can think of it as a Google map of our network. Here the spokes register the public IPs with the hub, and they can query it to find the best path to each other. Now, we need to learn the routes of all our remote networks. That's where the routing comes into the picture. You can either configure a static route, or you can use dynamic routing protocols such as EIGRP or OSPF. And finally, since the data is going over the public internet, we wrap the whole thing in IPSec for security. IPSec actually encrypts the traffic between different sites. So in this video, we are building a complete DVPN network from scratch. We'll configure the hub and two spokes with multi-point GRE. The hub is located in the HQ and the two spokes are located in the branch location. So we'll configure the hub and spoke with multi-point GRE and use NHRP for dynamic discovery and lock it all down with IPSec encryption. So in this lab, I have the hub with LAN and WAN interfaces. LAN interface configured with 192.168.1.0/24 and WAN interface with 1.1.1.0. And similarly on the branch side, I have on the branch one, I have configured 192.168.2.0, which is our LAN network for spoke. And then for WAN, I have 2.2.2.0. Similarly for branch 2 as well. So let's start with the configuration on the, and before that, let me tell you, I have already pre-configured the IPSec profiles. We just need to implement it at the end. And also I have configured the underlay routing between R1, R2 and R3 so that these are reachable via internet. So let's start with our hub router first. The hub router, we need to start configuring the tunnel first. So before that, let me show you what I have configured. So as you can see, our LAN interface is 1.1/0 configured with 192.168.1.1 and WAN interface with 1.1.1.1. So let's start with the tunnel configuration. Interface tunnel 0. I will be using the subnet 172.16.0.0/24 for the tunnel configuration, for the overlay configuration. 172.16.0.1 and subnet mask of /24. Undo shut. And then the first thing after configuring the IP is we need to define the tunnel source interface. The tunnel source interface will be our WAN interface. So tunnel source fast ethernet 0/0, which is our WAN interface. And then we need to define the encapsulation type, that is multi-point GRE. Okay, so with this configuration done, let's move on to the next feature, that is NHRP. To enable NHRP, I need to configure NHRP network ID. This is the command to enable NHRP. And then to allow NHRP to automatically add spoke routers to the multicast NHRP mapping, we need to configure this command on hub router, IP NHRP map multicast dynamic. So that's all the that's the configuration on the hub related to NHRP. And the last configuration that we need to add IPSec, will do it in the end. So let's move on to the spoke side now and configure the tunnel configuration of spokes. Let's check the physical interface is configured. 192.168, that is our LAN, configured on fast Ethernet 0/0, and 1/0, that is our WAN interface. Similarly, let me configure the tunnel here and assign the IP 172.16.0/2, no shut, then tunnel mode. Okay, before that let me assign the source interface, tunnel source fast Ethernet 1/0, which is our WAN interface, tunnel mode GRE multipoint. With this multicast GRE configuration done, let's move on to the NHRP. Let's enable NHRP by using NHRP network ID 1. This enables NHRP, and then we need to configure different options, certain parameters here. Let's start with configuring the hub router as our NHRP next hop server, and for that the command is IP NHRP NHS. We need to configure the tunnel IP of hub 172.16.0.1. This is our hub IP. Then we need to configure the IP to NBMA address mapping. So for that I need to configure, and this is the command, IP NHRP map, then the IP address of the destination, that is the tunnel IP of hub 172.16.0/1, and then configure the public IP WAN facing interface of R1, that is 1.1.1.1. Another command which we need to enable is to allow, send multicast from the source to the hub. We need to use this command, IP NHRP map multicast, and you need to use the public IP of the hub. So this completes our NHRP configuration. Let's go ahead and configure R3 as well. To configure R3, we can just copy some configuration from R2. Before that, let me configure the IPs on R3. Interface tunnel 0, IP address 172.16.0.3. Then rest configuration you can just copy. I need to define the source interface. The source interface is FA/1/1, and then rest configuration we can just copy it. GRE multipoint. So this is the configuration. Okay, NHRP configuration is done. So let's verify the tunnel. Show IP NHRP. Okay, so tunnel is fine. Show interface tunnel 0. Tunnel is up. The third thing we need to do is enable routing between those tunnels. For that I have I'll be using static routes. I will use the static routes from the defining LAN network, and the next hop will be the tunnel IPs. So for on R1, to reach the spoke 2 and spoke 3, I have created this static route. The next hop the next hop will be the tunnel IP of that spoke. So let's start with R1 first. Okay, and R2. And then R3. That's it. The routing is done. Now let's enable the IPSec. IPsec configuration is already pre-configured. I will just apply the profile on the interface of the tunnel. And the command is tunnel protection. Command is tunnel protection IPsec profile DMVPN profile. So this is the command which enables IPsec protection on the tunnel. Let me hop on to other devices and implement it. Okay, so the fourth part is done. We have already applied the IPsec. Now comes the important part, verification. So first let's go to the R1 and see if the DMVPN tunnels are up. Show DMVPN. As you can see, the peer sessions are up with spoke 1 and spoke 2, which are our branch 1 and 2. As you can see, it confirms these are the tunnel IPs and the state is up. So similarly, you can go and verify show DMVPN. It has tunnel up with R2. Now let's go to the devices and see if they can reach. Okay, so I'm on PC2. Let me try to ping 192.168.1.1, which is okay, here you can see it's pinging. Also, let me try to ping .10, which is the PC IP of the hub. I can ping the PC IP. So let's try to ping between two branches now. To ping between two branches, let me hop on to this PC. Okay, and then ping. This is PC2 located in branch 2. Okay, let me try to ping branch 1 location from branch 2, which is our 2.10. I should be able to ping. Here you go. We are able to successfully ping. Now, another important thing we need to verify is whether the traffic is going through the tunnel or not. For that, let's use the traceroute command. Okay, and then see. Here you can see the traffic is passing through the tunnel, which is a 172.16.0.2. Another few important commands which I want to show you is show commands. Let's hop on to R1. If you want to verify like if this IPsec session is up, here you can see the tunnel is up and active. It will give you all the details required like IC version 1, IPSec. If you want more, then you can also check verify using command like I think these are the command you can use to verify the sessions. Like that's it for this session. I hope this was informative for you. Please do like, share and subscribe for more videos.